This lesson is powerful string manipulations in C#. The objectives for this lesson are to learn the difference between string and string. What does immutability mean? The many string properties and methods that you're going to use almost on a daily basis. How to include special characters in strings using escape sequences. The power of string literals and string interpolation. And how to increase performance and manage memory better using the StringBuilder class. I would highly recommend you take a look at the Microsoft string documentation at this URL because they really go into a lot of depth. I'm going to give you a really good overview, but they'll give you just a little bit more. Now, one of the things to remember is when you're working with C#, you should use the string keyword with the lowercase s as opposed to the string with the uppercase, which is the string class. They are equivalent. They are the same thing, but in C# it's recommended you use string lowercase. Now there are different ways to initialize a string. You can do string name equals double quotes. That's an empty string. You can do string name equals using the string class dot empty constant. It actually gives you the same as what you see there, the double quotes. Or you can also use the var keyword. So var is basically a compiler hack that says the compiler will figure out, based on how you declare this variable, what data type it should be. So all three of these are equivalent when declaring and initializing a string. Well, let's take a look in our program.cs of declaring and initializing strings. Besides the ones that I showed you on the slide, which are there on lines 1, 2, and 3, you may also just initialize it to some valid value, like on string name equals helmet, line 5. Or line 6, string description equals new, and then you can specify the string that you want. I've never seen that one used, but it is one way that you can do it. Now another one, which is kind of cool, is string asterisks equals new, and then a character, comma, and then how many times you wish to have that character repeated. So I've spit out here onto the console on lines 9, 10, and 11, the name, the description, and the asterisks. Let's go ahead and run, and there are our values. So you can see those 40 asterisks displayed there. So just some different ways that you can initialize strings. Let's discuss the concept of immutability. Strings are immutable. What does that mean? It means that once they're created, basically they're there, they can't grow, they can't shrink. Even changing by a single character can cause issues, because what has to happen is a new area of memory is created, then the old string is copied to that new area of memory with any changes. That old memory area is now marked to be released. It's not released yet. The releasing of old memory is handled by .NET at some point, and the problem is we really don't know when that point will be. So you could see that if you're in a big loop and you're changing a string constantly, that your memory could really grow. The usage of your memory could grow, and that could be an issue. Now, if you are changing strings a lot, let's use what's called the StringBuilder class, and we're going to cover that just a little bit later in this lesson. Here's an example that can cause memory issues. I have two string variables, one name1, one is name2. They each have a certain amount of characters in them. If we look at this line that says name1 equals name1 plus name2, that's where the problem happens, because what has to happen is the compiler says, wait a minute, you're now changing the value in name1. It creates a new area of memory. It then concatenates name1 and name2 and puts that in that new area of memory. It then changes the pointer of this name1 variable to point to that new area of memory, and it informs .NET that this old area of memory now needs to be released. So that's an example of just a simple thing of string concatenation can actually cause memory usage to increase. Let's take a look at some of the most popular string object properties and methods. There are two properties. There's an indexer, which allows you to access a single character. So if you had a variable called name, you could do name subscript some index like 0, 1, 2, and access the single character out of that string. The other property is called length. Now there are many methods. Here are some of the ones that you'll probably use most often. Compare, concat, contains, EndsWith, format, IndexOf, IsNullOrEmpty, join, LastIndexOf, replace, split, StartsWith, Substring, ToUpper, trim, trim end. Like I said, there's many more, but these are the ones that you'll probably work with most often. Let's first take a look at the string properties. The first property is the length property. I've declared string name equal to 10-speed bicycle, and then we're going to display on the console name.length. If we run this, it comes up with 16. So there's 16 characters within that string variable. Next, let's take a look at the indexer that I talked about. So here I'm going to do a console.writeLine on name subscript 3. So what it's going to do is it's going to look at 0, 1, 2, 3. So what it should give us then is the S. So it's a way to index into this character array that we call a string. There's also in .NET 6 a new range operator where we can do ... and then how many characters we wish to go from 3 up to 8. So if we run this, we get 3, 4, 5, 6, and 7. It's up to, but not including that last number. Let's now start taking a look at some of the most common methods. The first one we're going to take a look at is the compare method. I'm going to declare a string called name and set it equal to the string 10-speed bicycle. I'm then going to, on line 3, do int result equals string.compare name, comma, 10-speed bicycle. What the compare does is it checks the first parameter against the second parameter and finds out if they are equal or where the other one would sort in relation to the other one. It's either going to sort after or it's going to sort before. This compare method will return an integer of a 1, a 0, or a -1 depending on where it sorts. So let's go ahead and run this one. And this should return a 0 because they are exactly the same. They'll sort in the same place. So think about an array of strings and we're sorting that array, for example. If we change that second parameter on the compare and we remove the E, this means that the name is now going to follow the second parameter when sorting. The second parameter is going to come first in the sort order, so it gives us a result of 1. In the last example of the compare, I've added some characters now to that second parameter, 10-speed bicycle space 1, 2, 3. That means that name now precedes that second parameter when sorting, and that means we're going to get a result of -1 when we run this. Let's now take a look at the substring method. The substring method returns to you a subset of the complete string based on the parameters that you pass in. So for instance, again, I have string name equals 10-speed bicycle. When I do a name.substring, I specify the starting position and then a comma and the number of characters to retrieve. So it starts at 0 and retrieves the next 8 characters. So if I run this, we get 10 speed. So it's not the whole string, it's just those first characters. Now this can actually be simplified. I could actually use that range operator now that's available in .NET 6. Now if you're using something prior to .NET 6, you won't be able to use this. But if we run this, we should see I get the same exact value. Another thing we could do is we could put this back and I could do a substring 9, for example. That says start with the 9th character and go forward through the end of the string. So now we just get bicycle. So lots of great uses of the substring method. There are also methods that allow us to query what's in the string. Is one string contained within another string? Does one string end with something else? Does it start with some particular character or set of characters? Is the string null or empty, or does the string contain a null or white space? Let's take a look at these different methods. Our first example is contains. So bool result equals name.contains 10 speed. If we print out the result on the console, it should say true. If we change this so that it no longer contains that string within the other string, it's going to return a false, just like you'd expect. The next method, EndsWith. You can find out, true or false, does that string name end with some value? So in this case, cycle, or you could even just use a single letter. That's fine too. Whatever you want to do here, and all you would do is then print out what you want, or use this in an if statement, right? That's typically the good use of these contains and ends with. If name.ends with cycle, then do something. The next method, StartsWith, also returns a Boolean, and it simply says, does the string start with whatever the value is? And it can be a single character or a string. In this case, it's going to report a true. Our next example is IsNullOrEmpty. On line 1, I declare an empty string, and then I do the test to find out, is that string null or empty? If we run this one, it says it's true. Even if I just add a single space here and I run this, it's now going to say false because it's no longer empty. It actually has something in it. If you wanted to check to see if it had just empty spaces in it, you can use the is, null, or white space. Now, I could actually add as many spaces here as I want, and when I run this, it's going to return true because there's nothing else in there except white space, and that's the name of this method. If you wish to find the location of where a certain string or a certain character starts within another string, you can use IndexOf and LastIndexOf. If you wish to find out where the index number of where something is located in another string, we use the IndexOf method, and it returns an integer result. So if I run this, it returns 9, and that's because bicycle starts at this 9th position. If you have repeating characters or repeating strings within a string, you can find the index of would actually give you the first one, but if you want to search from the back, you use the last index of. So now it's going to start back at here and go back until it finds the first speed. Index of would look forward and find this one. So this one's going to return 0, 1, 2, 3. But if I do last index of and I run this, it's going to return 21 because it's now saying, well, if I search from the back, that one starts at position 21 from the beginning of the string. So methods that can come in really handy when dealing with strings is converting a string to an array or taking an array and making it a string. We do that with the split and the join methods. In this example, I create my string name equals 10 speed bicycle, and then I have a string array called ARR equals name.split. And what I'm passing to split as a parameter is a space. What it's going to do is create an array of everything up to the first space. It creates the first element, and then everything up to the second space, it creates the second element, and so on. So if I now run this, I can then iterate over this new array that I've created from 0 to the array length, and it should spit out 10 speed and bicycle. So it got 3 individual words out of there. It considers the end of the string as also part of that split. The opposite of split is join, which means if you have a string array with 3 items in it, 10, speed, and bicycle, you can join all of those together into a string. So string name equals string class dot join. What do you want to separate each of the elements with? So in this case, it's a single space. And then what is the array to use? And it's this array ARR. Now we have a string that says 10 speed bicycle that was created from each element of the array. Sometimes you may wish to change the way a string looks. We can do that with format, ToLower, ToUpper, trim, trim end, and trim start. Let's take a look at each one of these methods. String.format allows you to take a string that has some placeholders in it. A placeholder is something enclosed in curly braces and has a number. And that number then corresponds to a parameter. So string result equals string.format, name, comma, 10, comma, and then the string blue. So what happens is anything with a 0 placeholder gets replaced with that second parameter, 10. And then anything with a 1 gets replaced with that third parameter, blue. If you had some additional parameters, you just keep numbering them. And you can even go back and have more than one of these in the same string format. So a 2 means that it's looking for one more item here being passed to string.format. So if we run this, we see 10 got replaced at the 0, speed bicycle, blue got replaced at 1. In the 2, it was that value 1 more, and then I put 0 at the end again, so it comes up with a 10. So it's just a positional thing as far as the numbers relating to the numbers of the parameter after the first parameter. So, and you always want to make sure that the number of parameters in here matches up with the number of parameters here. We have a ToLower method, which will take that string and make it all lowercase. There we go. Everything's lowercase. Or we have the ToUpper method as well, and that will just make sure everything is all uppercase. Consider this code where I have string name equals space, 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 10 speed bicycle, space, 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 space. I'm going to display the name and then the name.length. Now I'm going to use the trim method, name equals name.trim. So what it does is it trims both sides, both the beginning and the end of the string. It trims off any white space. So if we run this, we can see the original string, and then we see how many characters it is. It's 24. After doing the trim, we see that the front spaces are gone, and you can't see it, but the back spaces are gone. And we can definitely tell that because of the length after we've done the trim. Now we also have trim end, which simply trims the end of the string. And you can see that here. You can still see the forward spaces, and you see it's now 19 as the length after we trim the end. And then we also have trim start, which trims off the beginning ones, but doesn't trim the end. And you can see again that the number is different. Now sometimes with a string, we need to put in some special characters into that string, and we do that with what are called escape sequences. We use a backslash to put one of these special characters into a string, and there are quite a few of them. These are the ones you'll probably use most often. So remember how we delimit a string on each side with a double quote. If you need a double quote inside of that string, you can put a backslash and then a double quote, and that double quote will appear in the string. Or if you need a backslash, you just simply do 2 backslashes, and that will give you 1 backslash in the string. Or if you need a new line, or a form feed, or a carriage return, or a horizontal tab, or a vertical tab. These are just a few of the escape sequences available to us in C#. So let's take a look at some of the escape sequences. What I wanted to do inside of the name string here is I wanted to put the blue in double quotes. So I use a backslash, double quote, backslash, double quote. The backslash then escapes this, and now you can see the end result is simply the double quotes around blue. Because remember, we are using the double quotes as the delimiter for a string. So if we want to use it in there, if I didn't have a way to escape it, it's going to not really understand what I'm doing. So we need to have a way to escape this. What if we wanted to put a new line character in? We would do \n, and what it does is it moves that down to the next line. Now this is only going to work on those things like a console app where you're displaying this and it'll respect a new line character. As another example, maybe I wanted some horizontal tabs, so I would use a /t in between each word, and then I also put back the double quotes around blue. If we were to run this, we now see 10 and then a tab and then speed and then a tab and then bicycle and then a tab and then, in quotes, blue. Another example would be using a backslash, and this would happen a lot if you're using file names in your application, because maybe you're working with files. Well, you know how we have a backslash? Well, backslash is an escape character. So in order to get a single backslash, we have to use 2 backslashes as shown here on line 1. When we display this on the console, it comes out as a single backslash. If you remember the last sample that I showed you there with the file name, sometimes when you have a special character inside of a string, you can put an @ sign before it. This is called a verbatim string literal. And then when you do that, you don't need to use the escape characters. So now our path could look like this. Let's take a look at doing this in C#. So now look at line 1 where we have string file name equals @ sign, and then you can put in special characters and they'll just be verbatim. So :\samples \test.text, and then look at line 5, string value equals @ sign, :\n, which you remember was a new line, test \t, which you remember was a tab. If we now run this, you can see that everything now just comes out verbatim. It's not trying to escape any of those characters. Here then is another sample of using verbatim where when you do an @ sign, you can extend a long string over many lines, and where you put the spaces actually matters. Watch this. So now you can see that those match up exactly with the spaces there on lines 2 and 3. If I were to do this and run, we now see that they line up. Let's take a look at string interpolation. Now, interpolated string literals are prefixed with the $sign character, and we use interpolation to improve the readability of string manipulation. In fact, what this does is it replaces string.format. Remember that method I showed you earlier where you had to put in the placeholders like curly brace 0, curly brace 1, and then you had parameters that you had to line up? That was a mess. What we do now is we use curly braces with the actual variable name within it that we want to replace. So this replaces that variable's value into the string where those braces are located. Let's take a look at string interpolation. So here I've created an int id equals 1, string name equals bicycle. Now look at line 4, string result equals. Start it with a $sign character. Now I do id equals, and then in curly braces, id. The id matches to that variable declared on line 1. And then comma name equals, and then within the curly braces name matches up to the variable on line 2. So when I run this, it does the substitution, and look at how easy that is. We don't have to worry about positionally matching things up to the curly brace 0, curly brace 1, etc. Now let's take a look at the StringBuilder class. You're going to use this class a lot, and this is to help us with that string immutability problem. It's in the system.text namespace, but this allows you to append as many strings as you want. It pre-allocates space to help with memory management. So even though you say that, hey, I'm going to create a string here that is 10 characters long, if you know that you're going to concatenate other things to it, put it in a string builder. String builder will pre-allocate space. In fact, you can even specify how much space you wish to pre-allocate if you kind of know how much data is coming in. So let's take a look at a simple example of the StringBuilder class. On line 1, do a using on the system.text namespace because that's where the StringBuilder class is located. On line 2, StringBuilder SB equals new, and now I put in 1024, but I didn't have to. I could have left that blank and it still would have allocated a certain amount of size. And I can't remember each version of .NET, they've changed the size of how much they actually allocate. It might be 32 bytes, 64 bytes, I don't know. You could look it up based on the version you're using. Now, the string builder has methods like an append method, and I can append helmet. It has an append line method, and so I'm going to append a space dash space 1. It even has an append format, which is kind of like the old string dot format. So append format, you have curly braces 0, space, curly braces 1, and then you specify the parameters after that match up with each one of those. Then, once it's done all this building, you can get the complete string back out by doing sb.toString. Calling its toString method returns all of the string data that you put in there at one time. We go ahead and run this, and we now see the helmet-1 and 10-speed bicycle-2, which was built by using that append format there. Definitely use the string builder. It's very helpful when you're concatenating things in a loop. Definitely take a look at this and learn how to use this. You will use this a lot. Well, we have covered quite a bit in this lesson. I mean, we saw how the string data type has just a lot of properties and methods that we can take advantage of. We can manipulate strings in a multitude of ways: verbatim strings, interpolated strings, string.format. Now, just be aware that you can hit potential memory problems with strings, so definitely take advantage of that StringBuilder class because that will help with some of those issues. Coming up next, in the next lesson, we have using the properties and methods of numbers, dates, and times.